Hello, Prem. The
Jennifer?
last time we were together, it was at GTC in San Jose.
Yeah, we're making this a bit of a roadshow.
I know. And here we are at Evident AI. Capital One scored #2 overall in the AI index. You scored #1 in talent. Congratulations.
Thank you.
So it's interesting. We would love to understand about, Prem, you and your journey, coming from Amazon Alexa, the AI team, and then pivoting to financial services, making the transition as the chief scientist and head of AI and data for Capital One. Talk to us a little bit about that transition, your observations. Are there any parallels that you've come across in those two roles?
No, I have to say, like, the thing that drew me to Capital One was kind of the reputation that it had for being a tech-forward bank. I mean, it was with some trepidation that I was going from like a history of having worked in tech companies, whether it was in the DARPA world or for some time in academia, and then at Amazon. And so I kind of, the tech forwardness of Capital One was a bit of a reassuring factor in my deciding to go there. But once I got there, the thing that I found most striking is kind of the platform centricity of Capital One's approach to technology. There's been a long-standing conviction from what I can tell and what I've observed, that platforms are the way to deliver scale and value to the enterprise and to all of the lines of businesses across the company. And we tend to build, for any big initiatives on any big capabilities, tend to build things as platforms that then all the lines of businesses can build applications on. And we found that platforms provide you tremendous vectors for scaling, whether it is scaling the impact of talent. Tech talent is not inexpensive. Whether it's the impact of speed, your go-to-market speed in terms of taking applications, products, and services and offerings to your customers. Or, and most importantly, in a banking context, your ability to scale your risk and well-managed governance processes, because if things are on a platform, you can build a lot of your risk and governance capabilities into the platform. Mm-hmm. And so, so that part has felt very familiar to me in a way from the way things are done in big tech and especially at Amazon.
So Capital One is such a tech-forward company. You are a tech company in finance. How do you make decisions on which models you use, which tools you use, softwares and frameworks?
Yeah, so, you know, our CEO likes to say we are building a tech company that does banking. And there's a lot of reality to it that I experience in my day-to-day life. But when it comes to our approach to building stuff, the main thing we're looking at is what we're building kind of a core differentiated business capability? In other words, how much of our business and how much of our business knowledge are we building into this technology in order to unlock its full value? And it turns out that for most of huge majority of the things we do, the unlock of technology comes from deeply embedding knowledge of your business into that technology. And so we, over time, have realized that we have to build. There are things that we will buy when it is undifferentiated, like Amazon likes to say, leave the undifferentiated heavy lifting to us. So we're all in on the cloud. We are, I think, perhaps the only bank that's all in on a single public cloud. But all of these clouds have so much geographical resiliency and failovers that the benefits, the developmental benefits, and the ability to attract top talent because you're on a modern tech stack, these are all very important aspects to us. So that allows us to build fast and efficiently and build modern applications and modern.
So at GTC San Jose in March, you actually got a shout out from Jensen, our CEO, during his keynote. You launched Chat Concierge, your agent. Could you talk a little bit about Chat Concierge and what's new, any new developments since then?
Yeah, I mean, Chat Concierge is basically a step up from how we leverage our overall GenAI platform. As I was saying, we kind of have a platform-centric approach at Capital One. So we, right from the start, like, you know, the first half of 2023, we've been building our own GenAI platform. Of course, it's built on top of our cloud. We use S3, we use all the elastic compute services. GPUs are not elastic, so we use them too. But on top of it, we build our whole stack of all the layers of the platform, starting from foundation models, model gateways, other kinds of services, and then a whole host of what we'll call reusable capabilities, but you might think of those as patterns of use. And so one of the patterns of use is how do you leverage agents for certain types of tasks. And so we have our own agentic framework that for the tasks where you need multiple agents to come together and collaborate to do the work, people can build that and developers can build those things. And so Chat Concierge was the very first application that we built with that framework. It was also, I think it caught Jensen's attention because it was the industry first launch of an external facing launch in financial services. Chat Concierge is an application developed by our auto financial services organization on top of our platform. And it's used at many of our auto dealers use Capital One software. And so Chat Concierge is now helping them with the front end of their interactions with users who are coming in to explore what vehicles are available, things like that. And so we built it and put it out. If you're living in some geographies, in fact, you can go use it because many dealers across the country now have it, and that go-to-market team is taking it forward from there.
So when you think about the opportunity of AI agents, you mentioned that your agent, it's critical to train it on its own data. You mentioned foundational models. What do you think are some of the possibilities within banking, right? So a lot of the past 2 years has been all around Gen AI and back office productivity gains. AI agents is unlocking the opportunity within banking to have agents make decisions on front office money-making decisions. What do you think is next within agents?
I think, let me take a step back and maybe just say how we view agents. I mean, because there's been this thing, there's generative AI, there's a model, the model has a lot of capabilities. Many of those capabilities resemble human cognition, and that we found that exciting. And so our collective imagination was inspired by suddenly this thing, because you can interact with it, and it kind of interacts with you like a human. That was kind of the inflection point that unlocked imagination across the world, because you could relate to it. It was not somebody telling you, I've used a lot of data, I've trained a machine learning model, you don't know how it's doing, but it's helping you improve your life. And in fact, we've been seeing those effects in our lives without fully recognizing that it's AI. Like the fact that you go to your favorite streaming service and you get movies that are largely the ones that are interesting to you is really a fair bit of machine learning and exploration happened there. But it's not the AI that you're interacting with, it's the content or stuff you're interacting with. And so that was not quite as inspiring. But then when you went to this chatbot and you're interacting with it and it's responding to you, all of a sudden you're actually directly interacting with the AI, and that sparked kind of collective imagination. Starting from there, we then started applying these things to a lot of problems in the enterprise space or even in the consumer space. And over time, two capabilities have evolved over the last couple of years. One of them is this thing called reasoning. And reasoning is, at its core, the ability to take complex things and break them down into atomic things in a way, like simpler things. And so reasoning is a pretty important capability, even though we tend to think of it in the context of math and logic and stuff. But in the practical software development sense, if I can take a complex thing I have to do and break it down into simpler things, boy, now I can write things, right? And the other part is the specialization of these models. And so, especially with the open weights models where NVIDIA, we're grateful for Neutron and things like that, but also Llama and Mistral, the capabilities, those things have allowed us to bring massive amounts of proprietary data to these open weights models, to very deeply customize these models so that they do things in the way we want to do them, in the ways we recognize and are used to doing them, produce content in the styles and formats that we want them to produce because those are enterprise standards, etc. And so when you combine these two things, and then I'll say the context for agents was set. Now, from what are agents? It's simply put, agents are semi-autonomous entities that are able to navigate, understand their environment, take some actions on your behalf. I think the semi-autonomous is important because in a regulated industry, you don't want things to be completely autonomous and going and pulling all kinds of switches and levers. So there's a fair bit of guardrails, et cetera, that are built into this system. But when you think of all of these together, even you look in the open literature right now, there are tasks like the SWE benchmark, software engineering benchmark, which is one of the benchmarks that people test these models on. You take the same base model and you apply it to the SWE benchmark, and you might get something like, in the case of GPT 3.5, I think you were getting some answer in the mid 40s. I don't remember the numbers exactly. But then you cast the same problem as an agentic problem. All that means is you're using reasoning to break it down into atomic tasks and then executing those atomic tasks and orchestrating them and doing it in an appropriate way and then reconstituting your solution at the end. It turns out you can get 25, 30 point bump in those things. And we are finding, even internally, very simple tasks that at first blush, they look like they're composites, that this thing has to be done on its own. But then when we spend a little bit of time with the business partners, the employees doing this work, and try to break it down into the components and then cast it into an agentic thing, then we're able to harness the power of reasoning and the power of specialization. And that's making all the difference in many, many cases between things that stay exciting in the lab and are great demos to where there is widespread adoption and in production. And so each one of these things has taken us a while. We've not had successes that are just overnight and like we put something into production 3 months. There are times when we put things into production with very small numbers of users, get feedback, actually pause production, improve the application and the models, go it back, and then that scales beautifully into production. Everybody's contributed to the solution. It serves everybody. And in a world in which I think the noble aim of AI is to transfer the cognitive burden from the human to the system, at times when the human is feeling that cognitive burden most intensely, I think it's magical when they tell you exactly where the burdens are and you build the models and the applications, and then agentic just happens to be a very elegant way to deliver those capabilities and solutions.
It's a really exciting time right now at NVIDIA working with financial services customers because finally our financial services customers are talking to us about training their own foundational models. We at NVIDIA have been talking about this for several years now, and we train our own foundational models at NVIDIA because we have got to create the software frameworks and the tools for our customers to do so. So it's really exciting to hear that a lot of our customers are starting to train their own foundational models specifically for agents. You have to train it on your data, like you had just mentioned, Prem, it's critical. So let's just say if Capital One were to train their own foundational model, how would you do that?
So let me first make it clear. I think we have to retain the optionality to train our own foundation models because who knows how the world is going to change and what might be the availability of different models and how many different advances happening across the world might need to be synthesized into something that you want to build for yourself. Having said that, right now, our approach to it is foundation model training is not a one-shot thing. I think most people in the audience now know that. It's a sequence of things. And even when you think about something like pre-training, which we think of the first step in foundation model training, pre-training with the world's data in language or image, etc., is something that's a massively expensive endeavor. There's no reason for companies to repeat that. But then when you take those pre-trained models, if we have open weights models, like Nemotron, Llama, etc., then we can bring our own substantial troves of proprietary data to these foundation models and continue, kind of deeply customizing these things, and not just supervised fine-tuning, but going further deep into actual additional iterations of customization. We see these things lift performance. And beyond just performance in an accuracy perspective, a couple of important reasons to do this. One is I think the future is going to be when we look at inference costs, etc., On the one hand, inference costs have actually gone down by more than a factor of, between a factor of 1,000 and 10,000 in the last 20 months, right? So we're in an environment where inference costs are dropping dramatically. But that said, even at that low end of the inference cost, we would still like to see more savings in order to make the deployments of these things more from a sustainability perspective, but also from an economic perspective. Customized models allow you to get the same performance with much smaller models that are task-specific performance. They work much faster and they perform at much lower latency. All of this means if the speed is faster, the throughput is faster for the tasks that you're involved in, things are much cheaper for you, much more inexpensive at inference because most of your costs are inference costs. On the latency side, we all know this. User engagement is completely driven by latency. How much you will engage with something, and this is a lesson I learned from my Alexa days as well. If you have to wait a long time for an answer, you can see those use cases start dropping off. People don't engage, because we associate speed with ability. May not always be the case, because Einstein was supposedly not the fastest thinker, but he was a pretty deep dude, right? But we associate speed with facility and correctness, but also in this world, we want things to come back fast. Latency improvements, I don't think we will be able to achieve what we've been achieving with some of our, like Chat Concierge, et cetera, the latency that we need to deliver for that to be useful to our dealer partners without this deep customization. So thank you all for making these open weights models available so that the expense that humanity is incurring in all of these models is actually coming back to them in the form of services, et cetera, that they can do because we can bring our data to these models.
So you talked a little bit about inference. You spent a lot of time talking about training. So inference and production. How do you ensure long-term success for your models in production? And then are there any other considerations now with these reasoning models?
Yeah. So your question is really, once you've deployed things, how do we ensure post-production success in a way? And we've long thought about production as the deployment into production as really the first step in the AI stairway to heaven. It's an important step. It's the first step. You can't skip it. But then there are so many more steps before you reach that destination that you're headed towards. And a lot of those have to do, they're enabled by platformization. A lot of those have to do with whatever you do in the lab and how much ever time you spend in soaking things in beta use or in pilots, et cetera. Ultimately, it's really in production where you start seeing the realities of the world interacting with the applications and the models that you've done. So you need to bring all of that data back to keep improving it. In other words, you may if your job is to build like a really smooth sphere, you kind of get the rough thing there, and it's like the potter, they build it, and then they see the roughness, et cetera, and then you use a different potter's wheel to do something and smooth it out. In that sense, that data has to come back that tells you where are the gaps in what you've seen before. What are the ways in which there's also a Heisenberg here, in that once people start interacting with these things, their own anticipation or expectation of what it can do changes. So they start expecting more. And that manifests itself in the way they interact with the systems and the things they ask these systems to do. And so without constantly learning, there is going to be no AI that is successful that can't learn post-production. And not all of that learning has to be unsupervised. Some of it can be, some of the large gaps will have to be filled by bringing it back. This is where I was saying, in some cases in pilots, we actually pause. We bring it back, we make improvements, we do it. But then there's a lot of ongoing refinement. The last thing in this post-production world is that the world itself is changing. One of the big things that machine learning-driven advances, even before AI, did for us is that when you try to build systems without machine learning, with more rules and logic and stuff, you could, even if you could do it, you could only do it for the state the world was in at the time that you built the system. But the world is constantly changing. It's constantly evolving. And it's represented in the data that you can collect from that world. So if you have models that can learn from that data, then they're learning the changed state of the world, and their performance keeps up with it. Otherwise, with machine learning models, their maximum value, just like cars, when they roll out of the parking lot into the road, into production, After that, with every mile, their value depreciates faster than you want them to. So they have to then be improved and tuned to keep up with the state of the world. And so that's important. So for that, we build into our platforms a fair bit of observability, a fair bit of logging and instrumentation, how to correlate these actions, the time, there's so much detail. AI is really a team sport. There's so many people across the organization, the risk people, the strategy. Everybody has to play their role, the product folks, TPMs, engineers, scientists. There's just so much nuance into the details. The God of AI success really lives in the details of how you approach this thing. And so we pay a lot of attention to the benchmarks, the observability that we build, the tooling and the instrumentation and the telemetry.
Let's talk a little bit about talent. So Capital One is a big innovator within financial services. You ranked #1 in the Evident AI Index for talent. How do you hire and retain top talent?
Yeah, maybe there's a couple of points there, Jennifer. One is a lot of it also has to do with our overall approach, our technology approach, because the kind of company you are and the culture that you have has to be appealing to the people with the right talent to want to come and work there. A lot of people want to come and say, "Can I learn here?" Right? And one of the things we do, as I was talking about all of this telemetry and stuff like that, there was some talk of ROI, previous things. I'll just say the ultimate ROI is a happy customer. So there's a lot of proxy KPIs you can have in between: speed, latency, cost, etc. But we vector towards, is the customer going to be happy with what we're going to do, right? Everything else, when you work back from that destination, everything else is just technical detail, right? And so that kind of vision or approach is very appealing to many technologists. And so at the first thing, that's the kind of technologists that we're trying to hire. We also I have long believed, and as I've shared with Alexander before, talent is destiny. And so your destiny, when we are investing in talent, we are investing in our destiny. And if our destination is a happy customer, the happiest customers will be served by by products and offerings and services that are built and maintained by the best talent in the world, who is incentivized by having that happy customer. That's what we're building. Beyond that, I'll say we also take kind of a little bit of a collaborative view with the rest of the world. In the last few years, if any of you have been following some of the things we're doing with universities, we've set up multiple multi-year strategic partnerships with top universities in the country and in the world, starting with Columbia University right here in New York. And then the next one was the other coast, USC, which I've long been part of. And then in between, UIUC is our most recent center. And then we'll set up, these are all like multi-year, 5-year centers with commitments of funding. We invest both in the research work, faculty members, and in PhD fellowships. The idea here is not so much to generate massive amounts of IP or anything. It's largely, we think by bringing the real world problems to these institutions, we're helping to create a national STEM talent pool, especially in AI. We will partly benefit from it. Many other folks will benefit from it too, which is fine. But that kind of investment also creates a channel for collaboration for our scientists. Scientists and AI researchers and all, they want to be part of a global community. And so we're giving them that gateway to that collaboration with the top minds in the world. It also allows us to bring perspectives. What might we be missing? What are some of the emerging ideas that we need to be paying attention to, et cetera? And so that brings in a fair bit of it. The last thing I'll tell you, a lot of talent is inspired by the fact that, and I certainly believe this, there's a lot of talk about AGI, right? And maybe one of the ways in which people talk about it is in the context of driving, cars that can truly autonomously self-drive in the world. What do they need? You need good maps. you need well-constructed roads. You need to have lots of exits on the road so you can get to your local destinations, etc. From that perspective, what we're really saying is it's not the natural world that we're trying to navigate in. It's a human-created world. In that sense, I think enterprises are the human-created worlds. And so if we write the right documentation, if we create the right APIs, etc., I think the first manifestation of AGI might actually be EGI. I'll call it, enterprise general intelligence, where you can have things navigate, because enterprises are entirely human designed and created. And if we can document that creation and design in a good way for AI to learn from and follow, I think, so anyway, all of you, I'm sure, are equally motivated by the notion of EGI. So I think if we all get together, I think we can give the AGI people a run for their money by first bringing EGI to life in this community.
Thank you, Prem. It's always a pleasure.
Same, Jennifer. Thank you.